Cool. So recording in progress. Cool. So yeah, I'll just reintroduce myself, Mike Willett from Finna. If you came through the meetup group online, you would have seen that I'm the organizer of that. The idea was to set up fun things for the Java and Kotlin users of Stockholm to get involved and meet new people. We haven't actually had a face-to-face meetup yet due to COVID, but this will be something that we move on to do as well. Just got some cool information from everyone, people writing in. So we've got people from Malta, Belfast today, Vienna, Switzerland, various places within Sweden, Italy, Nigeria, Germany, Ukraine, Israel, Tampa, US, Tampa Bay. I don't know if anyone's a hockey fan, probably ours. We're in Stockholm, but they've been doing pretty good the last 2 seasons. But yeah, I'm going to hand this over to Bruce Eckel. We're lucky enough to have Bruce Eckel, I'd say, hosting this one and giving us some insight. So Bruce, yeah, take it away. Let people know what we're going to be covering and introduce yourself a little further.
Sure. Also, can you reiterate where people can put questions?
Yes. Okay, cool. So
put it in the chat, maybe.
Yeah, we're hoping to, get everyone's brains thinking and so on. So if there are questions coming in, if you look at the bottom of your screen, there's a chat option. You can either directly message me if you want to be anonymous with your question, or you can just slam it into message everyone. What we'll do once Bruce has stopped speaking, we'll get a chance to go through those questions. So yeah, obviously make as much use of Bruce as you can whilst we've got him here. We're lucky to have him here. So yeah, any questions you got, fire them in, and we'll make sure we get them answered before this ends.
Cool.
Cool.
Okay. So I've been, well, I'll show you in a second the books that I've been working on. And I just finished updating one to introduce all the features between Java 8 and Java 17. And one of the examples I looked at, I thought, boy, wouldn't this, I want to see what this would look like in Kotlin. So I rewrote it in Kotlin. And I thought comparing the two examples would not only introduce the Java 17 features, but also give this interesting contrast between Java and Kotlin. So you can see my website, MindView LLC, has links to my blog post, and you can find my under About, you can find my all the things I've done in the books I've written, etc. And then down here at the bottom is these examples are under my GitHub repo under pattern matching, so you can find both of them there. All right, so what's going on here? I see. I've been doing a podcast with my friend James Ward for about a year, and we have been enjoying it. And that's kind of our baseline, is it's got to be enjoyable, otherwise we stop doing whatever it is that's not fun. Anyway, we get to interview all kinds of interesting people in the programming world, and we've been having a really good time. In fact, Friday we put out 2 podcasts because the Z-Verge people were up here, and I'm not sure, I mean, not everybody will know because this is a Scala pure functional effects library, which that's a whole nother story. But anyway, they were up here, so we got to interview a couple of them for the podcast and talk about all kinds of interesting things. So, and you can listen to them on pretty much everywhere you want, and there's no ads because we don't like ads. So some of you might know me from my book, Thinking in Java, and then this more recent book on Java 8, and you can find it at this URL on java8.com. And this is only an ebook because it's way too big, although a Chinese publisher reached out to me and wanted to publish it in Chinese, and I don't know what they're going to do, because once they realize how big it is, they might, I don't know. Anyway, it's everything. And So they asked me to add sections that would cover the new features between Java 8 and the Java that just came out, Java 17. And I was struggling with that for a while, just because how do you integrate them? Finally figured it out. So there are all these standalone sections that their code compiles, but doesn't compile under the normal Java 8 build, so it doesn't break that. And they're scattered throughout the book. And those of you who have this book already, I haven't done the update yet. I'm still getting some corrections coming in from the Chinese translators. And so I'm incorporating all of those before pushing the result out to the old host, which was Google Play Books. And then now it's on LeanPub. But if you go to onjava8.com, it'll tell you. I also, in January, just finished the book Atomic Kotlin, and that was really my learning process through Kotlin. But I have become a big fan, and maybe I'll make some fans here today. And then we already talked about questions. So what I will do is I've got these two examples, which will be side by side, but I want to go through the Java example first, and then see all of the new features that have been added. I think I've got most of them. Actually, I don't think I have an example of var in here, but most of the ones that are kind of been making a splash. So and these, again, these you'll find in the GitHub repo. So if you want, you can just go there and look at them now, or play with them or whatever. So so here's the Java version. And oh, I need to bring in Java util just to be able to say list of, and this is a new library feature, so you can say list of a bunch of things and it'll create a list for you, which is nice. All right, so the important thing here is we can have a sealed, you can have sealed classes or sealed interfaces. And so I'm creating as a base type a sealed interface called transport. And this, normally you'd have some operations in the interface, or even some fields, because interfaces support those now. So what the sealed keyword does is it says there will be a fixed number of these which the compiler will know at compile time. And there's two ways you can do this. You can say sealed interface transport, and then there's a way to list the subtypes of transport that you're going to define, and you do that if they're distributed throughout multiple files. But if everything is in the same file as it is here, we don't have to do that. And the compiler will say, okay, I'm assuming that all the transport subtypes will be defined within this file. And if they're not, you'll get a compiler error. And so, so that's the simpler way to do it. So I'm creating 3 subtypes of transport, and these are records, which to answer one of the questions that came up in the meantime, somebody said, what's your favorite new Java feature? And I would say record, which is something we should have had a long time ago, because it just solves a bunch of annoying problems that you have whenever you create a one term for this is the data transfer object. It's basically an object whose only goal is to carry information around. And so this makes it much simpler so basically what this is doing is creating a class. And you can see from the implements transport that it's actually, yeah, that's what you would expect from a class, is that it's, in this case, implementing this interface. So you're able to, this is just the class name, and the argument list is basically where all the magic happens. So in this case, what it's going to do is create a property ID. It's going to create a field ID, and it's also, and that field is private and final. So it's initialized by the constructor and you never change it. So this is the idea of a record, is you're going to initialize it, pass it around, and nobody will modify it. And this enables the record to easily create a hash code and an equals, so that it can be put in hash data structures like maps and sets, and primarily those things. So that normally in the past, you've had to do all that by hand, and the record just does that for you. So now creating a data transferred object isn't something you'd hesitate about. It's something you'd go, oh, obviously I will do it this way. Whereas before you'd say, all right, I'm gonna have to figure out how to implement hash code and equals and all the other things that I need to implement this data transfer object. Is there some way I can do it without all that work? Now it's not a problem. Another benefit of this is if I wanted to add another field here, doing it wouldn't entail a whole bunch of rewriting and checking, and so it just makes life so much easier. And it's really unfortunate that we didn't have this when the idea started appearing in other languages. Anyway, so what happens is I'm going to have a field called ID, and I'm going to have an accessor, which is just ID. Notice not get ID, which from Java Beans is the way you've done it. And I really appreciate that they didn't try and persist the use of the gets. And it's especially true here, because the only thing you can do is read it. And so, so just saying I want b.id, and in a language like Kotlin, as we'll see, you wouldn't actually need the function. It would still go through a function, but you wouldn't need the parentheses, so it reads a little better. But this is great for Java. So what I'm doing is creating 3 different records, and they each have a different field in them, and you can see the field accessors are reflected by that. And then all the rest of the stuff just works. So one of the things to notice here is that this is sort of suggesting a different style of programming than we're normally used to. Normally what we want to do is use what's called the Liskov substitution principle, which says transport should have the interface, and the subtypes don't add any methods to that interface. But here, and this is kind of the style that records sort of nudges you towards, well, you don't want to have the same interface for each of these things, because they're different, you know, they're different ideas. So we want to give them different names. And so now all of these subtypes have different interfaces. So they effectively violate the Liskov substitution principle. And what so that, like, you know, back in the C++ days, I was on the standards committee for its first 8 years. And so learned mostly for learning, and I did learn a great deal there. Back then we were just like, no, we're not going to do any type check coding. And doing a switch, basically we're switching on the type of T in this pattern match. And so previously we tried to avoid doing that. We tried to say, no, use the Liskov substitution principle and put everything in the base type and never modify things in the subtypes. So all of this is kind of pointing us in a different direction. And the reason it is safe is because the compiler makes sure that if we pass in a transport object, it's going to make sure that you have a case for each type. And if you don't, it's going to complain. So I've jumped ahead a little bit. One of the things I want to go back to is saying, okay, this, in particular, the pattern matching feature is still in preview in JDK 17. So you can, if you install Java 17, you can compile this, but it will insist that you put this flag in for compilation, and when you run it, you have to put this flag in because it's not finalized. And even when this basic pattern matching is finalized, there's other things that they're planning on adding in the future. So this feature will not be finished for several years, and even now to use it you have to enable preview. So just so you know that. All right, so I sort of jumped into to this idea of pattern matching, and I want to talk about it in more detail. So what we are doing here is
Bruce,
yes.
Sorry to cut you off. I just had a quick question. I don't know if it's going to be relevant if we ask it at the end, but someone, Jan just came in and said, what if it is a null? Will the switch return null, or is it guaranteed to be non-null?
I will get to that. That's
okay.
That's why I have all this null stuff in here.
Okay.
Yeah, that is actually a big point in this presentation. So
okay,
yes,
cool.
we will get there. All right, so first of all, what is pattern matching? Pattern matching is the idea that you're taking an object and you're checking it for various characteristics. So you could do this, and people obviously have, if in an if-then, a cascade of if-then statements you could get. You could say, if transport T has this characteristic or that characteristic, do these different things. So really, this is just a nicer way to handle that. But one of the big benefits from using pattern matching is that the compiler, from the structure of the language, the compiler knows what you're doing. You're comparing based on, in this case, just the type of the specific type of the T. So what we're doing is saying, oh, is it a bicycle? Is it a glider? Is it a surfboard? Right. And so what the compiler does, because it's a pattern match, it says, oh, if you don't cover everything, look, this is through IntelliJ. So IntelliJ says, oh, switch expression does not cover all possible input values. So it's telling it, it's able to say, and it's an error, it's able to say, oh, you know, this is going to blow up if you run into a surfboard because you haven't covered surfboard. So that is that's one of the important benefits of pattern matching, and that is actually what makes it tolerable to break the Liskov substitution principle. Because when you are dealing with inheritance polymorphism, you know that every case is covered because the different subtypes are all right there in the inheritance tree. So if I call a method in the base class, we know that every subtype has an operation for that method. So it's not unsafe. And the reason that Strustrup, way back in the C++ committee days, said, oh, we don't want to do this type check coding because it's risky if you don't know that you've covered all the types. You know, it's unreliable code if you don't cover all the types. So what the combination of the sealed interface and the pattern match does is allow you to almost do your own kind of different polymorphism. You know, I can pass in any kind of T here and it does something different. But in this case, and this is the kind of the next trick that we see in pattern matching, is that if I match on bicycle, it creates this, I think it's a variable, but it may also be final. Anyway, it creates this B here, which is of case bicycle. So notice over here, I do not have to match. I mean, I don't have to do any casting for this thing because not all transports have an ID. or a size or a weight. It depends on the type. So this creates this B bicycle. And then in the expression to the right of the arrow, and notice this isn't colon, it's an arrow. I'll talk about that. We can simply use B as if it were of type bicycle, because it has the ID in it. And the same with glider, and the same with surfboard. So, so that's kind of the magic that they've been working on, getting into this whole pattern matching thing. And so right now it's predominantly on just type. I'm actually, I think it's only on type right now, but they will expand it to other things over time. So now let's look at, you thought you knew what switch was doing, but there's a couple of new things here that they've added to switch. One is, while I'm returning the result of the switch, and traditionally switch has been a statement and not an expression. So a statement doesn't return anything, whereas an expression does. And what this is returning is a string in each case. And that's what I'm returning, and that's what we see in the return type. So, so that's a new thing. They actually had to change switch to so that it was an expression, and it's actually an expression or a statement. So it can mean two things. The other thing that you see here is this is not a colon, it's an arrow. Now, of course, if it didn't support colon as well, then it would be not be backwards compatible, and you'd break all the huge amount of code. So now so what they've done is they've overloaded the meaning of switch. So all the old code still compiles, but we now have the expression and the arrow. What the arrow does is it says, it's very similar to the arrow that you see in lambdas. It says, okay, I have this thing and it's going to produce this result. So this is actually yielding this result. And it's also built in that it's a break statement, whereas the colon, you still have to put in breaks. So that's, those are the changes, and those have been being trickled into the language over the last, I'm not sure how many versions that, so anyway, if you have Java 17, you have it. And in the book, I explain where these features were introduced. So now we have this overloaded switch, which has these multiple meanings, which I'm not sure where I should complain about that, but let's keep going. All right, so now in main, I'm going to create a list of these. So it's figuring out that these are all transport items because they all have the same subtype. So the compiler does that for you. So I'm creating a list of these items, these transport objects, and then I'm doing a for each on, so I'm running an operation on each one, and I'm using a lambda to define that operation. So it takes a T, which is a transport, and then it simply prints out the result of calling exhaustive, which is this function here, on each of the transport objects. And then for good measure, I guess I better try to see what happens when I pass it a null. And we'll deal with that in a second. And let's see. So, well, I guess it's time to, oh no, let's, right.
Actually, I had a couple of questions that came in. I don't know if you want to hear them now or save them to the end, but it was just in regards to what you were just talking about there.
Okay.
We had from Matteo, he says, what if the type of T can change at runtime among the possible records? Will the compiler complain? I know it does in Kotlin.
What if the type of T can change at runtime? I don't know. I haven't looked into that. I mean, I'm not even sure how you would do that. That sounds like a design patterny thing to me. In other words, you have a reference and you can point it from a bicycle to a glider. I mean, basically, as long as all the types are covered, the compiler's fine because it won't have anything that blows up at runtime. So if I may not understand that one correctly.
Okay.
What was the other question?
Is the B simply a lambda?
Oh, you mean when they define the B?
I'd have to unmute. I'll tell you what, we'll run through, and then when we come to
Yeah,
question time,
some of these questions may get answered in the process.
and
And I mean, how it's implemented, I may not know that. So, okay,
right.
so here is the output from running the program, which I did just now. And you can see that as it passes each one of these in, they do different things. And notice that in the records, the arguments are different types. This one's a string, this is an int, this is a double. And so it's doing different, you know, these are producing different types. So that sort of justifies the pattern match there. So you can see it's printing out its data. And then in this last one, when I pass null to it, because it's Java, so it's always possible to get a null in your system, it produces a null pointer exception, which suggests that, okay, like if I was to go down here and add this new record skis, then we go up here and we see this error message again. So switch expression doesn't cover all possible input values. All right, so it's checking for all of those as long as they're types, but notice that it isn't requiring me to cover null. And this is a new feature. You may not have seen this, but somewhere, I think it was before Java 17, they added the ability in a switch statement to cover the case null, which is awesome. But so if we undo that, it's fine. And also notice that IntelliJ gives us this little message that said, oh, you know, if you have the parameter null, it might throw an exception. Now, I was not aware of seeing this before, so I have the suspicion that this is an IntelliJ message. I haven't seen this when compiling these things on the command line. Yeah, in fact, I didn't. I would have paid attention to that. So I believe this is IntelliJ doing the extra work for you to tell you that, hey, something's a little out of whack. Then if I remove this, that goes away. Doesn't have any problem with this. But the fact is that case null is optional. And this is where I wanted to, this is where I'm going to complain, because I understand why they made case null an option, because if they didn't, you'd be getting warnings or error messages throughout all of your existing code. It would not be backwards compatible. So they couldn't do that with the switch statement. However, if they had simply left the switch statement alone and introduced a match statement, or Kotlin uses when, then they could have insisted on null in that. And so, and also you would have only had arrows for the actual pattern match, and you wouldn't have this duality between a statement or an expression and the confusion over the arrow versus colon, which I'll bet it's going to bite a lot of people. So I have no idea why, because it isn't about being frugal with keywords, because they've been introducing keywords, including one that has an underscore in it. For some reason, it didn't have to be. I don't know what's going on there, but so I'm you know, this just annoys me. All right, so I think we've covered all of those things. Let's see if I can get this to go away. Yes, we've covered all of those things. Now what I want to do, yeah, I think I've covered everything. So what I want to do now is compare this to the Kotlin version. And okay, and these are both in the same subdirectory, the code subdirectory, I think. So let's move this down so we can compare these. So different package. Notice I don't have to import anything. Even though I'm doing the same thing in main, I'm doing a list of. I'm sure that the list of here was inspired by the list of from Kotlin. So anyway, that's minor, but I don't know. I like little flourishes like that because it makes my life just that a little bit easier. Here's another small difference, which is that the sealed interface, they're both sealed interfaces, but for one thing in Kotlin, you don't need semicolons. And the other thing is they tend to do things like, oh, well, if what you want to put in there is empty curly braces, well, that's nothing. So you don't have to put anything in. So I like that. And then instead of a record, they use the term data class, which actually both of them are fine. I prefer data class just because I don't have to explain that a record is actually a class. So data class says, it's a class to hold data. To me, even Scala's, they use case classes, which doesn't immediately, I think data class is a nicer term. So, so anyway, same kind of thing, except for Kotlin has a little bit of variation. Those of you who haven't seen Kotlin, you put the data type after a colon after the identifier. Also, data classes in Kotlin can have vars in them. You typically aren't going to do that, but this is more just to be consistent with the way you define classes. You always have to say whether it's a val or a var, but the more functional we get, the more you try and avoid anything that varies. So the rest of the stuff looks pretty straightforward. Instead of saying extends transport, I say colon transport. So which is more consistent with this colon syntax. It's saying data class bicycle is of type transport, and that's how you do inheritance in Kotlin. So we don't need that extra keyword. I prefer this, but I'm used to it. So bicycle, glider, and surfboard are the same. All right. And if I were to, okay, here's another thing. Of course, in Java, everything has to be inside of a class, whereas Kotlin takes the more pragmatic understanding that everything doesn't always need to be a class. Very often, all you need are functions. And of course, a language which is a functional object hybrid is going to make functions easier to work with and not force you to do everything inside of a class. So I think ultimately the idea that everything should be a class was a mistaken idea. But anyway, so here is this function. And in Kotlin, we say what things are. We don't have this implied, this idea that's implied that if I give you a return type, then it must be a function. And that works. That's an improvement for a number of reasons I won't get into here. So here's my function. So this is a standalone function. And in this case, it was had to be inside of a class. But basically, it's the same, just a little shorter. So function object takes a transport and it returns a string. And then we can just say equals. And here's an expression that defines the result of this function. So instead of having to use the return, we just typically say equals. So in this case, we say is bicycle, is glider, is surfboard. Now, one of the things I want to point out is that the pattern matching in Kotlin involves many more options than simply matching on type. So presumably Java is just getting started with the matching on type thing. So this is just one thing you can do. You can say, is it a bicycle? Is it a glider? Is it a surfboard? The other thing to notice is that we don't have these new identifiers being created in the case of Kotlin. It simply says, oh, if T is a bicycle, then it does this thing called smart casting. So you can see the hint from IntelliJ is actually telling you that it's smart casting. So it says, oh, if it passes this test, then T is now going to be treated as a bicycle. And we can select the element from the ID element from T. This is, even though it looks like simply an access of a data structure, this actually calls a function, and you can overload or override that function if you want to. And so we see the same kind of thing. We get the size and we get the weight. So it's doing the same thing as this other exhaustive function. It's just a little cleaner. And also the pattern match can do a lot more. And then in main, I do basically the same thing, except notice that I have not put in the situation for null. And we'll explore that a little bit. Let's see, is that okay? We got the for each. Now, one of the things that I'm doing here is instead of the full lambda that I did in the case of Java, I'm using this abbreviated lambda form that Kotlin allows, and I'm using the it keyword. And what it is instead of having to explicitly pass the T in to the lambda expression, it goes, oh, if it's just one thing, you don't need to have the arrow in the argument, and there's a default called it. So this is referring to each one of the elements that come in, just like this is the T is referring to that. So it's just a little nicer thing because it turns out we do a lot of lambdas. So we can see the same thing happen if we uncomment the skis data class. We'll get, now this is under the when instead of the T. And so it says when expression must be exhaustive, add necessary is skis branch or else branch instead. And it can do that for you. So like, if we were to say more actions, add remaining branches, it sticks it in there with a to do. That's nice, and the Java version doesn't do that. Whether maybe IntelliJ will get smart enough to do that, but this is basically built into the syntax of the language. So so it's much nicer in that case because it knows everything that went on, whereas when we did it over here, it said, let's see, it was up here. So notice it's on the T instead. It just says switch expression doesn't cover all possible input values. And let's see if IntelliJ, oh no, IntelliJ will do that. Oh, and it returns a null. How nice. That shouldn't be a problem. Null. I'm being facetious. Okay. So let's take that away, and we will take this away. Back everything up. Okay, so now we're back to normal. All right, now the next thing that we'll do is let's add, oh, just, this is a small thing, but I noticed details like this. Notice that here we can't, even though there are parts of Java that allow trailing commas. Whoa, what just happened? This doesn't. This does not allow trailing commas. Okay, whereas Kotlin allows trailing commas everywhere, which is just a nice feature that I like. I think, not sure who started doing it. Anyway, we're gonna add a null here and see what happens. Getting so much. All right, a bunch of things started happening. All right. So when we add a null here, what happens? We get a message somewhere. Oh, here it is. Here it is. Okay, so we call exhaustive. All right, and now the language says, all right, the argument that you're passing to exhaustive is transport, but because you added a null to this list, what you need to be able to pass is a transport question mark. Transport question mark means it's nullable. All right, so, well, let's just do what it's saying, and we'll change transport to transport question mark. Uh-oh, now we got another red line. What is that? When expression must be exhaustive, add necessary null branch or else branch instead. Okay, so it's saying now transport takes a question mark. Now you have to handle the null. Whereas we saw before here, if I don't handle the null, it doesn't care. And I mean, IntelliJ helps us, but the language doesn't care. It's not an error to not cover all possible cases because I pass null and it just blows up at runtime. Whereas Kotlin says, no, you got to put the null in. Let's see what it says, add remaining branches. Okay, so here's the null and it requires a to do. So instead of just returning a null as the Java one did, it actually forces, it's gonna say, hey, you haven't filled out this code. So I consider this much more helpful because everywhere in Kotlin, it nails down all of the nulls. So you're not chasing null pointer exceptions everywhere. So, okay, yes, undo add remaining branches. I'm going to take the question mark off. Then I'm going to take the null away. And we're back to normal. And so if we run this, we will see. Okay, it does the thing, but it doesn't let the nulls escape or appear without forcing you to handle them. And I think, I mean, for a lot of companies, because somebody said, oh, is Kotlin going to take over from Java? And I would say, well, that's an individual company issue. And for a lot of companies, if they become aware that their programmers are spending a lot of time chasing nulls, that's a pretty compelling reason to consider changing to Kotlin. And the way Kotlin was designed versus Scala is Kotlin was designed to be just seamlessly. So if I create a Kotlin component and I want to integrate it in my Java program, it just becomes a class file. And to Java, it looks like another Java class file. It can't tell the difference. And so, whereas with Scala, you had to jump through a bunch of hoops, you still do, in order to get Java interoperability. That wasn't their main thing. Whereas Kotlin, it's like, this allows you to say, well, we got a bunch of code that we believe is reliable and tested. We want to introduce new code, but we don't want to, introduce these new issues. Let's do the new code in Kotlin and leave the old code in Java. And that makes the transition much, much easier. So I think that is going to, that's going to make a big difference. All right, I think I've covered as much as I wanted to on this example. So let's go to where are the questions, or how am I gonna know what they are, Mike?
So
Are you there, Mike? Yes.
yeah, I'm here. What I was thinking of doing is opening it up so people can give more context to their question, because I think just me reading it out sometimes might not necessarily make sense. So I don't know if someone
well, how many questions do we have on the list?
I was going to open it up and ask people if there were questions now. So
well, it's just, I don't know. I mean, if there's a lot of questions, that
there's not a
process
whole bunch.
slows it down a great deal.
Yeah,
and so that's why I can answer the written questions a lot faster than I can answer the anyway.
Yeah.
We can just do what you'd like.
Okay. All right. George Smith has put his hand up here. I'm gonna unmute him.
Okay.
Yeah, I asked the question about whether or not in the Java side where we have the variable and the arrows, is that just a lambda?
Oh, you mean, oh, I suggested, oh yeah, look, this looks like a lambda. I don't know how the implementation works on that. I haven't looked at the bytecode. But that would be, I mean, if I was to try and figure that out, that's how I'd do it. I'd make the simplest possible example of this and then compare the bytecode with what the lambda would look like.
Thank you.
Cool. Harris, do you want to ask your question? I'm not sure I'm going to read that very well. I've just offered to unmute you.
Okay. Well, I'm just asking, like, did the Kotlin upgrade to where you can actually check a generic type and decide if it's data class? Because in Java, they solved it by simply implicitly inheriting records.
Boy, I wish I had my co-author here because she would be able to answer that. She knows the internal structures of these things. I cannot answer that question. I apologize.
No worries. All right. Unless anyone types in, I think that was it.
Well, we had the questions that came beforehand, right? Did I cover all those?
Okay. Yeah, they were in an email. Bear with me. So I emailed them to you, but
yes, let's bring that up on the. See if I can find that. Okay. Oh, my phone's frozen. Okay, let me see.
so I've got them here. If you want
Okay,
me to,
here we go. No, I just found them. What's the closest approach one may take with JDK 11 to mimic function extensions? I've never thought about that. Especially with JDK 11, extension functions. Yeah, you know, I think that's a unique feature. I'm not even sure how you would go about doing that. And I don't know whether they'll ever add them to Java, whether they think that might be like one of the things you can find this on the internet. There's a lecture that or a Ask Me Anything or something that Brian Getz gives, where he talks about one of the problems that they're working on, which is that Java serialization and deserialization has always been very insecure. It's basically an invitation to run any code on the receiver that you want. There are tricks that you can do. It was just not well thought out, and it's a little shocking that only now is that become a focus for solving things. Records will help this greatly because you'll be able to limit serialization and deserialization to records, which is typically what you're wanting to do anyway. You're not wanting to ship code across the wire to be run on a foreign machine. That's just asking for it. So if you say, okay, serialization and deserialization, some new improved version will only use records, then it can take care of so much for you and keep it secure. So I'm not sure why I got off into that, other than that's an important thing. Oh, I guess what I'm saying is that it seems like problems like that, fundamental problems with the language, is probably a better place for them to be spending time than adding new features, which I think this sort of relates to one of the questions that we have. I just don't know how many of these new features are going to be used, because if you're into pattern matching, you're not going to want the limited version that Java has now. You're you're somebody who's looking forward and you're going, I want to use these new features because it's going to make my life better and my company's life better. So if my company doesn't want to change to Kotlin or some other language that has more produces more reliable code faster, then maybe I want to change to a company that does that. So, and those people, maybe they're already gone. And the people who are happy with Java, it's doing what they need to do, and they've managed to get all the important bugs out of their system, then they're probably just going to stay with Java and not use these new features. That would be my guess. I think that's probably the biggest reason that a company or a person may or may not change. Is like, are you happy with Java the way it is? Then probably you're not the person who's going to be using all of these new advanced features, or company more importantly. So that I think answers a couple of the questions. Are there any new Java feature syntax that you think were designed better in Java than Kotlin? The only, well, I've been working with functional programming for a while now. And so anytime I see an opportunity to use a var, I always think, that's too bad. There will be mistakes made because of that. At the same time, it's like, well, I mean, Kotlin, it's possible to use vars. So what I was getting to is, I do like the fact that when you create a record, this is always going to be, ID is always going to be final. And whereas when you create a data class, you could make ID a var if you wanted to. And that's it. But there's lots of things that you could do that are non-functional in Kotlin. So maybe this is just a very pragmatic choice. It probably is. Anyway, that's probably the only thing. I mean, there's so many other things which I could go, oh, I don't know why they did that. I'm guessing that I have the benefit of hindsight. Will Kotlin replace Java in the future? For some companies, it will. For me, it will. I'm also doing a lot of work in Scala now. So which of the new features do you personally like the most? Records. It has to be records. I think that simplified things. And that's something I could see a lot of people starting to use because they already use add-on libraries that create the equivalent of records for them. And so I think that'll just be kind of a no-brainer for people to use, even if they don't use any of the other more intricate features that were added to Java. This one, I think everybody will understand right away and say, oh yeah, I want to use that. Okay, and let's see if there was any other questions that came up. Data class has the copy feature. Yes, that's it. You can't copy, and there's another feature that you can't do with records. But I know copy is one, and I thought that was odd. I thought it was odd that they didn't do everything, and there might be some underlying reason that that is the case. Maybe that was a design decision, but because I mean, every data class or case class or Python even has, I think they even call it data classes. Everyone I've seen has a copy function in it. It's inherited. Let's see, can you test if Kotlin is a generic type data class? You can test if it's inherited record. I'm not sure I understand that one. Oh, here's a new message. Does Java have an equivalent to Kotlin's objects? So Kotlin's objects are like, I think static inner classes would be right. Yeah, okay. Yeah, so that's what it would be. It's there, it's just more ceremonies required. Right. Okay. All right, I think I've kind of grasped everything. So if anybody has another question, now is the time to put it in. Otherwise, that will be all.
Excellent. No, thank you,
Okay.
Bruce, for your time and your presentation there, and thank you to everyone that came out. Yeah, well, virtually.
And let me know when you get it up on YouTube so I can tweet the URL.
Yeah, I will do. I'll do my best. I'll figure that out.
Okay.
Yeah, I'll sign into Zoom and make this available. There was quite a few people that messaged me
Yes.
saying they want to look it back. So
Cool.
no, excellent. Well,
Right.
yeah, thank you
Well,
for
it
your
was
time.
fun.
Yeah,
Yeah, I enjoyed it.
good stuff. And yeah, feel free to drop out now, guys. And yeah, we'll get something else booked in for the community again soon, hopefully.
All right. Okay, I will. Let's see, how do we get out of here? No, not that one.